This is Matt Farina, and welcome to the October 31st meeting of SIG-Apps. Today we have a few demos, stand-up, some open discussion. But before that, I will paste the agenda. If you want to add notes or anything as we go along, I appreciate any help in keeping notes. We have one announcement, and that is if you're going to be at KubeCon, there is a survey to see who's coming to the SIG-Apps meetup. And I'll drop the link in to chat again. Please let us know if you think you're going to be able to come. This should be fun. It is Monday afternoon. More details will be emailed or have been emailed out, or ping me if you want more. All right, so with that, we have some demos. So we'll start with the first demo. James, are you there to talk about the Kubernetes plugin for Jenkins?
Yes, I'm here. Can you hear me okay?
I can hear you great. The floor is yours.
Let me just share my screen. This is my first screen share on Zoom. Let's see if it works. Can you see a screen?
Yes, we can.
Phew. Okay, that's good. That's a good start. So hello, everyone. My name is James Strachan. I'm really going to focus mostly on the Kubernetes plugin for Jenkins. But before I get there, I'm just going to talk a little bit about Fabricate and what that is and why we're using the Kubernetes plugin. So Fabricate is really a bunch of microservices for developers to use to make Kubernetes a developer platform for creating microservices. And the basic parts of Fabricate are, Fabricate has lots of microservices to help things. The main pieces are, there's a developer console that helps developers create microservices, look at all the different environments and watch versions and so forth, which we'll see in a moment. It uses Jenkins for continuous integration and continuous delivery. It uses Nexus as a repository manager for artifacts. If you use languages like Java or Node.js, you don't just release Docker images, you also release like NPM packages or jars or tables or whatever. Also, we use something called GOGS for on-premise Git repository hosting. Now, if you're lucky and you're an open source kind of geek, we can do everything online these days, right? We have free Git hosting on GitHub. We have things like Circle CI, which are all free for open source. If you're an enterprise developer, you kind of need an on-premise version. So that's where GOGS comes in. It's a Git hosting solution that runs on top of Kubernetes. Finally, there's something called JBoss Forge, which is a bunch of developer wizards for creating projects, editing projects, updating them, and so forth. So that's kind of Fabricate. The way we install it locally, if you have your own Kubernetes cluster or you want to boot up, say, Minikube on your laptop, there's a really simple way to install it. You basically download this little binary and run this command, go Fabricate start, and then it all boots up and it's all kind of simple. If you want to spin up Fabricate and the Kubernetes cluster on the public cloud, we recommend you take a look at something called StackPoint, which is really cool. It's literally a couple of clicks and it will spin you up a Kubernetes cluster on Google or Amazon or Azure or DigitalOcean. And they've now got the solutions option that lets you pick one of multiple solutions, of which Fabricate is one of them. There's also things like Prometheus and various other bits and bobs. So if you want to get started, those are the big two things I'd recommend. We do want to have Helm as our primary way of installing things. We've got a whole bunch of Helm charts right now. They're still not all completely working and testing, but they kind of mostly work. What we hope is all of Fabricate will be installed with a single Helm chart. It's not quite rock solid right this second, but hopefully within a week or two, that'll be the main recommended way of installing Fabricate by Helm. The big thing for us is it allows you to do upgrades, right? We can have a repository of versions and then do upgrades once you've done your first install. There's a whole bunch of other additional microservices, things like Chaos Monkey, ChatOps, Grafana, Prometheus, Kibana for looking at metrics and log events. And there's a whole raft of other ChatOpsy things and things like Archillion and SonarQube and Gerrit and all those kind of different integrations. But for now, we're really going to focus on Jenkins. So I'll do a very quick demo of using the Fabricate console to create a project with Jenkins and show you how the pipeline kind of works. Then I'm going to delve in and look at the plugin and how the plugin works. So here's a quick look at the Fabricate console. This is actually running on Minikube on my laptop. We're going to look at the team dashboard. We've got the current application called Cool Stuff, which I created just before this demo. You can see we have a testing environment, a staging environment, and a production environment. Each one of these environments is just a Kubernetes namespace in this example. Ultimately, you may have different Kubernetes clusters, and with federation and yada, 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 you would hopefully have a different production cluster, for example, or clusters. What I'll do to start with, though, is I'm going to create a brand new project, and I'll just quickly show you how that works. We have a bunch of different wizards for creating microservices using various things like Django, .NET, Node.js, Go, Spring, Swift. I'm going to do a Java Spring Boot example, and I'm going to call it Great Stuff. What we do now is we're going to spin up a Git repository in Gogs. We're going to spin up a Jenkins job, and what we're going to ask the user is to pick one of a bunch of different pipelines. Now, I've not really mentioned this yet. Jenkins 2 introduced something called Jenkins pipelines. And the pipeline is kind of like a workflow. It's a long-running job that does continuous delivery. So, for example, in this example, we're going to use canary release, stage, and approve to production. So let me create this project, and then I'll talk about what it's actually done while it's building and while the pipeline is running. So I hit complete. Now it's going to have created a bunch of source code, checked it into a Gogs Git repository, created a Jenkins job, and now that job is going to run. It's going to build the project, it's going to deploy it, it's going to run the system tests in the testing environment, stage it to the staging environment, and then after human approval, it's going to go to production. Now it's going to take maybe a minute to do the build on my laptop. While that's running, I'm going to switch apps for a second. Now, once you start using lots of developer tools on Kubernetes, you'll have your Git hosting, you'll have your Jenkins, you'll have your Nexus, you might have your SonarQube, you might have your Gerrit and your code review tools. You soon get lots of different apps. So we have this little menu that lets you switch between any app which has a service in Kubernetes which is annotated to indicate it's an app. So I can switch from the Fabricate console into Gogs. Here we can look at the Git hosting, and we can look at the Git repository we've just created. And this kind of looks and feels kind of like GitHub. It's not quite as awesome as GitHub, but it's really aimed at replicating GitHub for on-premise kind of folks. So we can browse the project there. We can also switch straight into Jenkins. So if you want to look at the vanilla Jenkins stuff, we can look at this new project it's created, or new job, Jenkins people call it. And we can watch the log directly in Jenkins if you wish, which is fine. What we've tried to do is give you a single pane of glass that shows you everything, all your environments, all your jobs, all the build logs, the pipelines that are running, the Git commits. So you don't have to keep switching and through hundreds of different browser tabs. But at the same time, we want you to be able to delve in if you really need those kind of things. So what this pipeline is going to do, it's going to do a canary release, it's going to version everything, tag everything with a new version number, tag everything in Git, then build the artifacts, push those into Nexus. If I flip into Nexus, we should be able to see artifacts being staged into the Nexus repository, which only really, it doesn't affect Go people, but it affects kind of Node.js people and Java people. You don't just release Docker images, you also release, here's the one I've just done previously, and we should see the next release appearing here shortly. We tend to release jars and POMs and tarballs and NPM packages and that kind of stuff. Once the release is done, we're also going to run a system test. We've been using Kubernetes to develop microservices for a couple of years now, and in addition to unit tests, what you really want to spend your time on is testing inside Kubernetes. You don't want to get the developers to run stuff on their laptops, because their laptop or naked laptops, running things on Mac or Windows is going to be very different to running things inside Kubernetes on Linux. So we want all of the system testing really to be running inside Kubernetes, ideally in a different namespace so it doesn't mess with your production environment. So the system test is going to run now. While that's going, I'm just going to look at the previous build because it's taken a little while, and I'll show you how that works. Now, what we've found is once you start developing microservices and they're moving through these pipelines all the time, so they're running through tests and soak tests and load tests and integration tests, and then they're being staged, and then eventually they're moving to production, you often want to flip between these different environments and see where things are. So from this one screen, we can see 101 is in testing and staging and production, and we can visually watch when running upgrades happen. Each one of these is a Kubernetes environment we can just click straight into, and we can look at the deployments in the staging environment. We can see when staging. This is the deployments. We can scale them up and down and so on and so forth. We can look at the replication controllers or replica sets. We can look at the pods. We can see that now a new pod has just been spun up because we've just scaled it up and so forth. So we can easily switch between all the different projects really quickly. 1 second, my browser's just on. 1 second. Whoa. The demo gods have struck. Okay, while that's going, I'm going to switch and talk about what's actually happening under the covers. Now, Kubernetes, there's a plugin for Jenkins called the Jenkins Kubernetes plugin. Now, what Jenkins is trying to do is use Kubernetes as a slave pool, so that whenever you run a continuous delivery job, it's spinning up a new slave inside Kubernetes. So it's really using the Kubernetes cluster as the slave pool, for those of you who've ever used Jenkins before. Now, until very recently, each Jenkins slave pod was just a generic pod. And increasingly, what you really want to do is you want to check in your... so a Jenkins pipeline is defined in a Jenkins file. Let me show an example of a Jenkins file. This is an example Jenkins file. So you check this into your Git repository as a file called Jenkins file. And this defines your entire pipeline for your project. Now, the important piece when you start doing continuous delivery is you kind of want each microservice to have its own pipeline, and for that pipeline to contain all of the tools it needs to do its build. For example, we're including the specific version of Maven in this example, the specific version of Golang. We might be using, say, web-based system testing, so we might be using a specific version of Selenium and maybe specific browser container versions and so forth. So what you want to do really is put all of the configuration for your build jobs in your Jenkins file, check that into your source code with everything else. You then have a versioned pipeline, which whenever you change it, it's a Git commit, and you've got history, and you don't have this problem that someone comes along and edits a Jenkins job and you lose all of your history, right? We want these to be long running, and we want these Jenkins jobs to be defined very closely with the source code. Now, one of the new things that's happened in the Jenkins pipeline plugin, the Jenkins plugin for Kubernetes is now it lets you define the build pod. In other words, it lets you define the exact Docker images you wish to be used in Kubernetes for your pipeline. Now, the Jenkins pipeline plugin has been around for a while. People have often used this with, say, vanilla Docker, and it's just run Docker containers for different stages. When you're using Jenkins pipelines inside Kubernetes, you really want to use a build pod, because that means that then you can share local volumes between your different containers. So you might use, I don't know, you might use some Make and some Go, and you might use some Maven, and you might use some Grunt, and then you might test with Selenium. You kind of want to, where possible, share the build output between the stages. The stages themselves, you define, you can demarcate your Jenkins file using the stage domain-specific language step. This then appears in your console as a different part of your pipeline. Then to use the different container images, you use this little container step. So here we can run a bunch of commands inside the Maven container, and here we're running a bunch of commands inside the Golang container. So it makes it really, really easy to define whatever pipelines you need. And these pipelines can be doing literally anything. They may be making Docker images, they may be running system tests, they may be provisioning stuff, they may be using Helm to provision things in different environments, they may be using kubectl, and so on and so forth. So that's kind of it. I wanted to keep it fairly short and sweet. I didn't want to talk too long about Kubernetes or Jenkins, but I've seen quite a few people on the Stack channel talking about how to use Kubernetes and Jenkins, and We've tried a zillion different permutations. We've tried Docker and Docker. We've tried all kinds of crazy stuff. This is currently the best way we've figured out how to combine Jenkins and Kubernetes together. You use a Jenkins file per project. You can use this little pod template thing to define what the containers are your build needs. And then in there, everything else in here is just fairly simple shell scripts running in a Docker container. Okay, that's been done, I think. Let me see if there's any questions.
So this is Matt. I have a question. So I see GOGS is used for source hosting. Companies are using a number of different options: Bitbucket, GitHub Enterprise, GitLab. What's the support like for these other things other than GOGS?
That's a great question. Well, from the Jenkins pipeline perspective, it works with any Git repository anyway. So from the Kubernetes plugin for Jenkins doesn't really care where the Git repository is hosted. From the Fabricate side, we have these wizards to spin up projects, and one of the wizards is an import wizard that lets you import from an existing Git repository. One thing we're missing right now is a nice wizard that lets you spin up a brand new project from scratch, but using Stash or GitHub Enterprise or GOGS or GitLab. So we're going to add that fairly soon because a lot of people use all kinds of different Git repositories. The important thing is that you can always create the project outside with Fabricate and then just import it from the Git repository. So there's always a way of bringing in anything you have in Git. One of the things we've done, so I come from a Java background and I've worked for many years with Java. One of the other things we've focused on very much is how can we take, a lot of enterprise customers have a ton of Java apps right now and Java projects that use Java and Maven. One of the other things we can do in Fabricate is we can just import pretty much any Java project that uses Maven. And it will automatically do the CI/CD Jenkins pipeline, make the Docker image, do the testing and so forth. So we do have a really good story on integration and migrating existing projects. But yes, we should improve our wizard for using different Git repository hosting services. The tricky bit is there's no standard way of making new Git repositories. GOGS and GitLab and Stash and GitHub Enterprise are all quite different in how they work. So we just need to abstract that a little bit behind the microservice. One thing I didn't talk about at all, by the way, was how to make a Docker image. I think Ben's going next. One of the challenges, which isn't anything to do with Jenkins, one of the challenges of making Docker images on Kubernetes is to do real Docker commands inside a build, inside Jenkins, Jenkins needs to mount the Docker socket, usually, which implies privileged containers, which implies possible security issues for different people. OpenShift has a feature called source to image, which essentially means Jenkins doesn't see Docker or touch Docker. It posts a tarball to a service in OpenShift, and it does the Docker build. GKE has a container builder REST API, which is a similar kind of idea. Rather than doing explicit Docker builds, you post a tarball to some RESTful service, and then it takes care of doing the Docker build. How different teams do this with Kubernetes, it kind of depends. Like if you're using OpenShift, you'd use the source to image builds to do the Docker thing. If you're using GKE, you'd use the Google container thing to do the Docker builds. Another option is you just have a Kubernetes cluster that just does Docker builds, and it's not your production or anything, it's just a build file. Or you could use Circle CI or something to do the Docker builds. So the one thing that's a slight complication is when using Jenkins and Kubernetes together is how you do the actual Docker build part. And you might want to descope that and do it outside of your cluster, depending on how you create your clusters. Any other questions at all on anything Jenkins or Kubernetes plugin for Jenkins or Fabricate?
Going once, going twice, going 3 times. Thank you for a wonderful demo. You've caught my interest with Fabricate. It's been a while since I've looked at it, and it's nice to see where things are going.
Thank you.
So next up, we have Ben. Ben, are you here? Ben, are you muted?
How about, can you hear me this way?
I hear you now. Did you hear me that time, Ben?
We lost you, Ben.
We'll give you just a moment. Technical difficulties. Can you try? No. Ben?
Hey, sorry about that. How about now?
That's quite all right. I can hear you now.
Okay, I was dialed in over the phone, and I guess those lines are muted or something. So.
All right. So I will, the floor is yours.
All right. So I'm going to go ahead and see. This is also my first time sharing, so hopefully it will go well. This demo is going to look actually somewhat similar to what James just showed. Similar concepts of Jenkins pipelines and things. We take a lot of the work that James's Fabric team does as upstream stuff and then sort of pull it into the OpenShift product. So you see sort of a different take on the pipeline integration experience as seen through the OpenShift user environment. So the first thing I'm going to do here is actually use the OC cluster up feature of OpenShift, which this just stands up a cluster, a Kubernetes/OpenShift cluster running on your local box. Uses containers to actually run the OpenShift master servers and a node and all of that, and pre-populates that environment with a little bit of configuration. So you have some user accounts set up and a few example images that are available to the system. All of that just gives you a quick and easy way to bring up an environment for a developer who just needs a cluster to play with. So this will just take maybe 20, 30 seconds to come up, and then we'll be able to log into the OpenShift console and start deploying the pipeline. And just to talk a little bit, James was talking about the constructing of images, and so that will be something that'll happen as part of this pipeline. So we'll actually be taking source code that resides on Git and packaging it into a new application image and deploying that image on our running cluster. So just taking you from end to end of a developer with some source code to a running image that they can then hit as a service that's deployed. So we've stood up things like a Docker registry within this cluster, a router, so that we can actually have external access to the applications that we're running. Image streams and templates. Templates are a concept that is being proposed as coming to Kubernetes, but for now is a way for OpenShift to package a bunch of API objects together in a way that's parameterized and easily deployable, and we'll deploy a template as part of this demo, so you'll see that here. So we've now got a OpenShift console available, so we're just going to log in, self-signed certs. So I'm just going to go ahead and bypass the good information there. And this is a secured environment, so I'm being forced to log in. Again, the OC cluster, I've actually pre-created this developer account for us, but you can add your own accounts. And it's also pre-created a project for me. So I'm just going to select that project. And so now I'm going to add something new to the project. So this is essentially a Kubernetes namespace or OpenShift project where you're going to have all your pods and services and things like that running. And what I'm going to do is deploy a template, which is going to create a whole bunch of different objects within this namespace for me. I'm deploying what we call the Jenkins pipeline example template. And so this is going to define a couple of critical things for us. So it's going to define a Mongo database deployment. So we'll get a MongoDB available. It's going to also define a service for that MongoDB. It's also going to define a build config, and build configs are an OpenShift specific concept for building that, turning that source code or other inputs into a runnable image. So we're going to have a build config that's going to construct our new application image, and then a deployment which will deploy that image for the application side, and that application will be talking to the MongoDB. So all of those things are being defined by this template. And then the last piece that this template defines is another build configuration of a different type that we call a pipeline build configuration. And pipeline build configurations, rather than producing images, are actually able to execute pipelines by talking to a Jenkins server, and the Jenkins server executes the workflow pipeline, the same pipeline concept that James was talking about. So the pipeline will execute on the Jenkins server, communicate with OpenShift, and walk through all of those steps. So here we're instantiating the template. We've got a few parameters that we can choose to customize the deployment behavior. So for example, naming all the objects, we want to make sure that we don't duplicate names that may exist already within our namespace. If we want to customize the host name, I'm not going to do that because I'm not running a full DNS server here, so we're going to be using zip.io. What repo are we actually going to build? So that build config that I mentioned is going to be building some source code from this Node.js example repository, but if I had my own fork of this, then I could change that to that value. We're also specifying the Mongo database name and username and passwords, which are going to be auto-generated. So again, we're running a secure Mongo environment, and the application is going to have access to those values because they're parameters, so we supply them to both the Mongo deployment as well as the application deployment. We also give the ability to customize memory limits if you want to do constraints on that, and number of other parameters that the template provides that are less interesting, so we'll skip through those. So I'm going to go ahead and just say create, and it's now going to create all of these things for me. The other thing that this is going to do, because I have defined that I want a pipeline build configuration, the system recognizes that I don't yet have a Jenkins server available, so and I am trying to do pipeline build configs, so it's actually going to automatically provision a Jenkins server. That's not the template itself asking specifically for a Jenkins server, but rather the system recognizing one is needed, and so it will be deployed. So if we go back to our overview for our project, we'll now see that there are a number of resources that exist. As soon as this refreshes. So we see a couple things. We see that we've got our Mongo, which is already deployed and running. We have our Node.js application, which has not been deployed because we don't actually have an application image for it yet because we haven't built it yet. And then we also have our Jenkins service, which again was auto-detected as necessary and is being stood up. So this will come up in about 30 seconds or so. And then we will have a Jenkins server available within our project that we'll go log into and see what's going on in there. In the meantime, we also can see the builds that were defined. So this is the build of the application itself. This is just a standard OpenShift build that's going to take source code and produce an application image that can run that source code. We can see the source is specified over here. If we drill down into it, we can see a little bit more detail about exactly how this build is configured. So again, we see it's using a source strategy build, meaning it's going to consume source code and produce an application image. We see what image it's going to output to. If we wanted to trigger it via webhooks and things, that information is also available. And then if we go to the pipelines builds, we can see the other build configuration that was defined by the template, which is the sample pipeline, which is actually going to orchestrate the entire build and deployment of our application. And we can see the Jenkins file that's actually defined within this build configuration. Again, the Jenkins file James was referring to. In this case, we see it's a very simple Jenkins file. So it's got two stages, a build and a deployment stage. The build is actually going to invoke an OpenShift build. So what we're doing here is that we're going to have a Jenkins workflow that triggers a build running within OpenShift, waits for that to complete, and then it's going to do a deploy stage where it, again, talks to OpenShift and triggers a deployment of that new image that we just built. OpenShift actually has the ability to just auto-deploy on a build where you can have a deployment triggered by the results of a build. So this is a bit of a convenience for the demo to show multiple stages happening, but it's a way if you wanted to have a more sophisticated pipeline where there was a stage in between of human approval or something like that, and then you would be able to have that within the pipeline steps. So let's see if we go back to our overview if our Jenkins server is up and available. Okay, it looks like our Jenkins server is up, so let's bring that up in a tab. And again, we've got a self-signed cert that we have to accept here. And so what we've done with our Jenkins image is we've enabled an OAuth flow so that when you're going to your Jenkins server, it is locked down and secured. And rather than having a separate Jenkins password that's managed locally by Jenkins, you can actually log into your Jenkins server using your OpenShift credentials. So we're going to log in with OpenShift, and it's going to take us back to the OpenShift login page. Again, we're logging in as this developer user, and then we're going through a standard OAuth flow of granting permissions to the so that Jenkins can see who we are, and that's going to actually control what we can do within the Jenkins server. So based on our permissions within OpenShift, we kind of map that to permissions within the Jenkins server in terms of, can I only view jobs or can I actually edit and administrate jobs? And so within the Jenkins server, we now see that we have this sample pipeline. This is mapped to the sample pipeline that I showed you in the OpenShift console. This is its representation within Jenkins where it will be executed by the Jenkins server. We actually like to think of Jenkins as being sort of, you don't have to go there. So this is for your information. Yeah, there is a Jenkins console. You can log into it. It shows you this. But we don't actually have to administer our pipeline from Jenkins. We can actually just go back over within the OpenShift console, and we're just going to start the pipeline from here. And when we start the pipeline here, this creates a build within OpenShift, and Jenkins will actually observe that that build has been requested. And so it has actually started executing the pipeline in response to us starting the build from within OpenShift. And you can also see actually it has spun up a node because the pipeline in question is using the Kubernetes plugin that James mentioned. So it's going to actually spin up a slave pod within our OpenShift cluster. And we can see that from the pods view, that we have this additional pod that's going to live just for the lifetime of the pipeline in order to execute the pipeline. If we go look at the pipelines page again, we now see that we have one instance of the pipeline executing, and it's currently in the build stage. This will take probably 30 to 60 seconds or so to fully execute. We can also see, because that pipeline kicked off another build within OpenShift, that we actually have the application build is also running within the OpenShift environment. And this is the build that the pipeline is waiting for. And if we look at the logs, we can see it's doing sort of standard NPM Node.js stuff to deploy that. And we can also, if we wanted to, view all of this information through Jenkins itself. We see Jenkins reporting similar pipeline information. And we have the actual execution of the pipeline in terms of its console information. So again, same information that you're getting through either console. So if you want to drill down into Jenkins and do it, you can, but there's really no need to unless you really get off into the weeds. Everything is orchestrated through the OpenShift console. This job does a little bit of testing on the image that's produced just to validate that the image is good. So we see it's now running those tests on our new application image, and then it's going to push that image up to the registry that we deployed within our cluster. And then once the deployment finishes, it will, or sorry, once the image push finishes, it will trigger the actual deployment of that new image. Let's just jump back over to the pipelines view. And we'll see it advance to the deployment stage once that push is completed. The push is going. This is all running on my laptop, so the registry is not the most high performance registry you could be running. So the push is a little bit slow.
And I think it's worthwhile to note, like, a lot of what we try to focus on from the OpenShift perspective is because OpenShift had to be multi-tenant from the very start. Like, most of the things Ben are showing are baked into like tenancy down all the way down the stack. And so like a lot of the like the reason why we have an integrated registry is we have integrated access control. So like the same RBAC permissions that can control Kubernetes that's now in Kube 1.4 and 1.5 are the same things that we're using internally and have been using to limit who can push to the registry. So when you have permissions to create a build, and then you have permissions to push to the registry, and that's integrated through the service accounts that are being used in the pods. And so it's this theme of authentication and access control all the way through. So we can, give to somebody and say, hey, this user in this project is totally isolated from this user in this project.
And so now that build completed, we see the pipeline now shows that we're into the deployment stage, and we can actually see that there is now a deployment running for that original application that we've now built. Looks like it actually has deployed. So now we can go over to our application, and we've got our super fancy welcome page, and we see that we've also got a database connection here with our page view count is all the information that we're storing in there, but connecting to that database that we deployed at the very beginning of this. So that's the whole thing. Basically just trying to give users an easy way to manage their pipelines from within the OpenShift environment while tying it in with all the other capabilities that OpenShift has in terms of building images and deploying those images. And again, you can do that all from within the OpenShift console, or if you want to drill down into the Jenkins management, then you can do that, again, just using your same OpenShift credentials, same permissions, sort of a single sign-on experience through the OAuth credentials. So that's it. Any questions?
Going once, going twice, going 3 times. Yeah, so thank you for the demo. It looked really good. Nice job.
Thanks.
I like it. All right, so we have one more demo today. Today's a demo-filled day. Do we have, is it Antoine on for the CNR server?
Hi, do you hear me?
I sure can.
Okay, cool.
The floor is yours.
Hi, so I'm Antoine. I'm working on packaging application, and recently we did, I was working on a server to store this packaged application, and I wanted to show, because it's maybe a good point to converge with Helm. So the idea is to have one server so we can push our application, fetch them, pull, and the main idea of it is it's reuse the OCI data structure. So at the end, maybe we can just serve both in one manifest, like you have your Docker image, you have your application manifest, and so on. So it's quite simple. So there is so currently it's called CNR for Cloud Native App Registry. It's just a temporary name, probably, but we have to pick one. So there is currently 3 projects. So one is a server, a Python client, and one to still write a Go one. So let's go quickly into the Swagger to see what's. It's quite simple. It's very small. So basically, you can just list the packages you have in the registry. Of course, you can post one. So to post a registry, to post a package, you just encode in base 64 your tar GZ and you post it. That's all it takes. Okay, and then it's in the registry. So you can precise the media type. So it can be M, KPM, or whatever, maybe even images in the future. And then you can list, for example, all the releases that are available, or for example, all the manifests. So here I pushed an Elasticsearch package, both for KPM and M. So the path is Elasticsearch, and here you can see all the manifests that are available for a particular version. Or you can just, okay. And after this point, you just pick, for example, the digest you want to download. and then you get the tag chart that can be used by M or Tiger or any other. Okay. So this is basically all the API. There is one thing is we call a release. It's a version. So why we call release? Because in CNR it's not mutable. So once you push one, you can't force push. Or you can't push it again. So for example, to get things like latest or canary version, we have an API called channel. So you can create like a stable channel, canary or beta, and just it's like a pointer to a particular release. So you can upgrade it and or rollback. So we have a channel API to just manage every mutable tag. And from the package point of view, everything is content addressable. So through the digest or directly the release name that comes change. Yeah, and so the media types could be like, let's say, any software we want to push a particular type of manifest. So the endpoints are quite complete. What's current work? So it's still in development. Current work is to get closer to the current OCI specification. So in OCI, every single reference are content addressable. So for example, this manifest is content addressable, and inside also until you get the blob you want to use. And so, as I say, one of the ideas to converge to this is like make it very easy for current image registry to add an application side, for example, Quay or GCR. And so we will be just push our image, push our application charts, and get them how we used to pull images. So one other advantage to want to converge one API is for example, the dashboard or UI will be very easy to, for example, I don't know, for Fabricate or any dashboard or Kubernetes dashboard, to have one single thing to search a package, one single reference API to fetch package, to search for them, etc. So this is the main idea. Yeah. So I tried to be quick because there was already a lot of demos. But that's the main idea. So I sent an email, so don't hesitate to, if you have a question or concern, any suggestions for this, we want open to discuss them.
So this is Matt. I have some questions.
Yeah.
If nobody else does. So I saw KPM show up in there, and I saw OCI images show up in there. What's the relation to holding Helm charts?
Sorry, I did not understand. Sorry.
So you talked about KPM packages, and you talked about OCI images. What about Helm charts?
Yeah, this is what I talk about charts. This is for, yeah. So this is the idea of CNR. So first, so it's like a natural place for any type of package. So maybe it was too small.
No,
Here it's so when we call a manifest, it's the particular type of package. So you can package an application, I don't know, Elasticsearch with M, with KPM, or maybe later there is another tool, or I don't know. And so we can have one concrete reference to push them, and it will be the same experience. So basically what the application will do, it will just query this URL and search for the media type it's looking for. So M will just fetch, okay, I'm looking for this media type, so this is the digest I want to pull. And KPM will just say, okay, this is a media type. My media type, I will pull this application. And if it's an image, it will just say, okay, this is a OCI manifest, and this is the digest I want to pull the image. This is the idea.
Okay. Now, for Helm chart repos, there's an API for that, sort of. Do you support API compatibility?
So the idea is like, I think it's not to. This API is to make to be a natural place. So no, it's very simple and.
Okay. Does anybody else have any questions? Let's see. There's a question in chat. So the question was, if I understand it, paths with more than 2 variables like API v1 namespace and any different variables in there are not authorized with Kubernetes authorization attribute. And then the response, I think, is this is more trying to be like Docker registry than like the Kube API.
Yeah, it's more like being Docker registry, because the idea is like to integrate such server and API into current existing Docker registry.
All right. Thank you. Are there any other questions? Going once, going twice, going 3 times. All right. So thank you for the demo.
Thank you.
And next up, we have Matt Butcher. Are you on? Talk about Helm. Let us know what's happened in the last week.
Yep, I'm here. He's still getting a weird echo.
If you're not talking, could you please mute?
All right. Yeah, so got a couple things to say today. First of all, this is a great opportunity to give a shout out to James. James, in addition to working on Fabricate, has been probably one of the earliest contributors to the Helm project and has filed a lot of issues and raised a lot of challenges that basically shaped a lot of the direction we took with Helm. So it was really cool to see the Fabricate demo, and I do want to thank him publicly for all the contributions he's made on the Helm project. Now, the next thing I'm going to say is probably going to cause the Helm team to come lynch me, but we are in really, really good shape in the Helm project. We have burned through the beta list of issues. We have just a few small remaining ones. So we may go into RC sometime this week. So we'd hit RC1 this week. And the goal of RC is just to make sure that everything's good and then to cut a final release. So we're really enthusiastic about where we are. This is a great time if you've been waiting to sort of see how Helm stabilizes and then kick the tires. This is a great time now to do so. We've got a pretty active list of support issues, so we're all trying to focus on helping people get started on various distributions of Kubernetes, and in so doing kind of learning which distributions are causing people problems and where. But really, we're in really great shape, so I'm hoping that the next time you hear from me, we'll be in the RC phase. That's all I got.
Fantastic. So if you want to go file bugs for Matt and the rest of the Helm team, I think now is a fantastic time to beat up on it and let them know before they release. So thanks for the update. With that, we now have the floor is open for open discussion. So if anybody has something they want to discuss, we have about 10 minutes left. The floor is open. Any technical issues, problems, anything we want to discuss before we go to KubeCon? Now's the time. All right, I'm going to say silence means there's nothing. So if you do have something, feel free to interrupt me here real quick. When we come back, we'll have a number of issues hopefully coming out of KubeCon. Remember, Monday afternoon, we are doing a face-to-face SIG-Apps. So if you're there, please feel free to come join us. And when we come back, let's shoot for hopefully a little bit less demo time and more discussion time. I'll have a number of things, and I hope some others do too. So if we don't have anything specific, everyone, I'll give you your 9 minutes back and have a wonderful week. And I look forward to seeing some of you next week. Bye.
Bye.
Bye.